Welcome and thank you for joining today's webinar. Before we begin, please ensure you have opened the WebEx chat panel by using the associated icon located at the bottom of your screen. If you require technical assistance, please send a chat message to the event producer. To submit a written question, please be sure to select all panelists in the WebEx chat, type your question in the message box provided, and press enter on your keyboard when you're ready to send. All audio lines will remain muted for the duration of this webinar. There will be no verbal Q&A conducted today. With that, I'll turn the call over to Liz Fernandez. Liz, please go ahead.
Good afternoon, everyone. I'm Liz Fernandez with the Professional Development Services Branch, and we have two speakers for today's webinar. Dr. Sarai Rivera Garcia is an epidemiology officer for USDA APHIS VS in San Juan, Puerto Rico. She received her DVM from the University of Missouri in 2007 and later completed an internship in food, animal, and production medicine and a master's of veterinary public health. From 2009 to 2012, Dr. Rivera Garcia worked as a large animal resident veterinarian at the University of California, Davis Veterinary Medical Teaching Hospital and treated a variety of livestock. In 2013, she joined the USDA as a supervisory public health veterinarian with the Food Safety and Inspection Service in Pennsylvania. She joined VS in 2016 and currently works with swine, cattle, avian, and small ruminant health programs in Puerto Rico and the U.S. Virgin Islands. She has a particular interest in tick-borne diseases and cattle fever tick control strategies and has participated in several projects in recent years. Our second speaker is Dr. Kristen Allfisher. Dr. Allfisher is a veterinarian with USDA APHIS Veterinary Services, currently serving as a staff veterinary medical officer on the animal product export team. Kristen began her APHIS career as a Saul T. Wilson Scholar in Northern California. She then worked as a field VMO with Veterinary Services in Puerto Rico, where she helped respond to the Hurricane Maria crisis and co-led the Puerto Rico Tick Surveillance Project. She later moved to International Services, where she served as an agricultural attaché supporting the Caribbean area. Prior to her work with APHIS, Kristen worked as an anthropologist chasing lemurs and working on One Health projects in Madagascar. When she isn't hiking in a rainforest somewhere, Kristen and her partner enjoy doting on their newborn daughter and their 2 dogs and 1 cat. And with that, I will turn the webinar over to our speakers.
Thank you, Liz. This is Sarai. Can everybody hear me okay?
Yep, your audio is good.
Okay, thank you. So today I will start us off to talk about a grassroots project that we did in Puerto Rico. It's basically a tick surveillance project, and its title is Non-Invasive Surveillance of Ticks and Tick-Borne Pathogens in Puerto Rico After an Ecological Disturbance. So to start us off with a bit of background, in Puerto Rico we have 2 ticks of agricultural significance. One of them is Dermacenter mittens, which is basically a horse tick, so horses are its preferred host, and it's a vector for equine paraplasmosis and equine anaplasmosis. Rhipicephalus microplus is the other tick that we'll talk about today, and it's the one that we will be concentrating most of our efforts. It's basically a cattle tick. It's also called, known commonly as a tropical cattle tick. Cattle is its preferred host, and it's a vector for diseases like bovine babesiosis and anaplasmosis. And then I wanted to touch base just a little bit on Amblyoma variegatum, because that is mentioned a lot, at least in our agency in veterinary services. So it's commonly known as tropical bond tick. And just want to set the record straight, this tick is eradicated from Puerto Rico, but it does exist in neighboring Caribbean islands, and it is the vector for hard water. So just a little bit of background on how this project even started. As many of you know, Puerto Rico went through a major hurricane, Hurricane Maria, in September 2017. Puerto Rico was struck by Maria as a Category 4 hurricane, and it resulted in massive infrastructure damage and ecological disruption. These pictures that you see here are basically pictures. The ones on the left and the right are pictures that we took. The one on the left is basically showing damage at a porcine premises, and the one on the right is basically some of the damage to our area office. So then moving on a little bit to talk about the diseases themselves and disease status in Puerto Rico. So in Puerto Rico, we do have pyraplasmosis, which is something different from mainland U.S. We've had studies done in the past. At the time that we started our study, the main data that we had was fairly old, as you can see in the references there. But basically it was found through those references that 89% of horses have been positive for Babesia cavalli, or samples submitted, and 25% for Theileria equi. I did a quick search of our databases, basically that have some of the, or have the NVSL submissions, which are the ones that we have access to, from September 1st, 2016 to August 28th, 2020, and basically found that 47% of samples submitted were positive, and they were all positive, or out of the ones positive, they were all positive for Babesia cavalli. Then touching on equine anaplasmosis, our status in Puerto Rico is unknown, but it has been found in samples taken from dogs. And in terms of bovine anaplasmosis and babesiosis, they are endemic in Puerto Rico. And at the time we started or did our project, our latest data was from 2007 from studies done by Dr. Uzas, which many of you know, which basically found a 27% prevalence in dairy cattle farms for anaplasmosis and a 26% prevalence in dairy cattle farms for babesiosis. Touching on just a little bit on brucellosis, which you will find out soon why. Basically, brucellosis, we are free of brucellosis in Puerto Rico. We've been declared free since 1981, but we have had samples in the past from Isla de Mona, which is basically a little island in between the Dominican Republic and the main island of Puerto Rico. And we have had feral swine surveillance samples done there that have tested positive for brucellosis in the past. So knowing that ticks are not really a major disease vector for brucellosis, we still included brucellosis in our study, as it could play some kind of role in at least assisting with surveillance.
So with this background and context in mind, Dr. Rivera and I came up with this project to address the following research questions. What is the prevalence of various species of livestock-associated ticks in Puerto Rico after Hurricane Maria? To be clear, we are not inherently attributing any changes in tick or pathogen prevalence or distribution to Maria. In other words, we weren't looking to Maria as a source of causation or any differences we found from previously reported prevalences. However, Maria was a major ecological disturbance, and we felt it was important to capture what the prevalence of both ticks and pathogens was in the aftermath, since we found it likely that the older numbers that we had were unlikely to be accurate. We also had no idea what effect the 2017 hurricane season might have had on the distribution of the tropical bont tick in the Caribbean, and we felt a tick-based project would increase our chances of detecting this tick if it had arrived in Puerto Rico. As a result, we decided that our tick collection end date was set to be 1 year after Hurricane Maria hit. So then our second research question is, what is the physical and host distribution of various species of livestock-associated ticks in Puerto Rico after Hurricane Maria? In other words, where are the ticks, both in terms of the geolocation and what livestock species were we finding them on? Our third question is, what is the prevalence of equine pyroplasmosis, equine anaplasmosis, bovine babesiosis, and swine and bovine brucellosis in livestock-associated ticks in Puerto Rico after Hurricane Maria? This one is similar to our first question, but in this case, we're thinking less about the ticks and more about the pathogens that might exist within their blood meal. Our fourth question is, what are the physical distribution of these diseases in livestock-associated ticks in Puerto Rico after Hurricane Maria? Again, this is similar to our second question, but we're thinking about the pathogens' geolocation rather than just the ticks. Due to the nature of this study, it's worth noting that we teased apart the question of pathogens and ticks simply because we were not exclusively interested in pathogens that were being vectored by ticks, but rather also the pathogens that were simply present in the tick themselves. As we had one AHT very cleverly put it while he was trying to convince a producer to help us out, we're just basically using these ticks to collect the blood for us. Our fifth question is, are ticks and disease patterns significantly affected by different geographical zones within Puerto Rico? I am not here to do the work of the Puerto Rican Tourism Board for them, but Puerto Rico is made up of some incredibly diverse habitats. And we wanted to determine if the various ecozones, as we call them, would have an effect on tick and pathogen distribution on livestock. And then our final question is, what is the value of using ticks to perform minimally invasive disease surveillance in livestock? At the heart of this study, we were functionally interested in this question. Could ticks help us do disease surveillance in a way that was easier than our traditional methods? For our collection methods, we examined cattle, horses, and small ruminants for ticks. While Puerto Rico has a large number of backyard pigs that veterinary services in Puerto Rico interacts with regularly as part of the inspection and surveillance system, no one had ever reported seeing a tick on pigs there. So we continue to keep our eyes out for ticks on pigs throughout the study, but we never saw one. And as such, we did not consider pigs to be part of the study. We did collect ticks from a small number of livestock guardian dogs to see whether they had any livestock-associated ticks, but this was done more incidentally and was not a priority of the study. Since our questions related more to the ability to detect ticks and pathogens at a premise level rather than an individual animal level, we pooled all the ticks collected from animals on a premise by host species. And I'm using the term species here somewhat loosely because we coded beef cattle and dairy cattle separately. So, for example, if we found ticks on 2 horses and 3 beef cattle at a single location, then we would submit 2 tubes for that premise, one for the horses and one for the beef cattle, but they were pooled together by those species. We collected from both live animals and beef cattle at slaughter, and we aimed to collect no more than 20 ticks per premise across multiple animals. The ticks were collected alive directly from the host livestock and put in centrifuge tubes containing 15 milliliters of 80% ethanol. We also recorded the following information that you see here for epidemiological purposes: the collector, the date, the GPS location, the owner, the host species, the number of ticks, and the number of host animals that the ticks were removed from. For the slaughter animals, we recorded or estimated the geolocation data of the premise of origin, not the slaughterhouse itself. We captured both premises where we found ticks and premises where we did not find ticks. When it came to our laboratory methods, processing ticks for DNA requires macerating them. So before that was done, entomologists at ARS and those under their supervision performed morphological identification of all of the ticks. We also followed up with some genetic identifications for some of these ticks to clarify any unexpected morphological IDs and make sure that they were indeed accurate. The ticks were then macerated and the DNA was extracted using the basic process depicted in the image here. Multiple aliquots from each premise were made both for the purposes of this study and for future work by ARS. And our laboratory partners at Texas A&M used qPCR to screen the aliquots for Rickettsia rickettsii and several species of Borrelia, Ehrlichia, Anaplasma, and Babesia, and then they performed conventional PCR to confirm any positives that were detected. The one exception to this overall process was bovine anaplasmosis, where the Texas A&M lab decided to go straight to conventional PCR. Texas A&M identified pathogen species wherever possible, with the exception of bovine Babesia IDs, which unfortunately became a COVID casualty, and are now going to be performed by ARS at a date to be determined. Our partners at University of Wyoming screened the ticks for both bovine and swine brucellosis. As you might imagine, we had a very low index of suspicion that we were going to find either of these pathogens for a wide variety of reasons. One, as Sarah mentioned, Puerto Rico is considered brucellosis-free. Another is because we didn't collect any ticks from pigs. And finally, brucellosis has an intermittent bacteremia that makes blood sort of a suboptimal sample under the best of circumstances. However, as mentioned earlier, brucellosis is a major disease of concern, and we felt the ticks posed a real opportunity to supplement our surveillance efforts for the disease. Overall, in that span of that year, we collected 2,184 ticks from 579 animals on 182 unique premises. We examined livestock at an additional 180 premises that were negative. Our goal was to examine premises across all of Puerto Rico, and we were successful in examining livestock on premises in 68 out of the 78 municipalities. Those municipalities that did not have premises examined were either in municipalities that were very small or just had extremely limited agriculture because it was an urban area. As you can see, over half of the premises containing beef cattle or horses had at least one tick found on those species. Meanwhile, a quarter of dairy cattle premises had ticks detected, and none of the small ruminant premises had ticks. As previously mentioned, the dogs were not a major part of the study, but all 5 of the livestock guardian dogs that were examined did indeed have ticks on them that were collected. Our tick species were split pretty evenly between Thermocentor nitens and Rhipicephalus microplus, which was also known as Brucellosis microplus, for those of you that have that old knowledge. One cattle premise had Rhipicephalus ticks that were tentatively ID'd as Rhipicephalus annulatus based on morphology, but we do have genetic tests pending on that particular tick, that particular premise of ticks. Again, the fact that we don't have the results is another COVID casualty. There were also 5 premises with Rhipicephalus sanguineus, aka the brown dog ticks, which, shocker, were from the 5 dogs. Given that we were only really interested in the role of dogs as they contribute to the spread of ticks and pathogens that could affect livestock, we eliminated these ticks from additional analysis. Here we have the host distribution of the ticks that we found. While we know that the Thermocentor nitens and Rhipicephalus microplus had host preferences, I think even we were surprised to find that the correlation between tick species and host species was perfect. Out of those 2,000 plus ticks, every single tick found on horses was Thermocentor nitens, and every single tick found on cattle was Rhipicephalus microplus, with the single exception of that one premise I previously discussed that we are calling microplus for the purposes of right now. This is despite the fact that horses and cattle were often present on the same premises and commingled together. So these next 2 maps show the physical distribution of the various premises we sampled based on where we did and did not find ticks. This first map here shows the negative premises as well as the positive premises, and the second one we removed the negative premises. Since host species and tick species correlation was perfect, these maps also show exactly where the tick species were found. These maps also depict the ecozones that I mentioned earlier. So for a little bit of clarification, along the north, you have the lower elevation rocky region known as the northern karst, and that's mostly in olive color. Along the central region, you have a higher elevation wet rainforest, which is in dark green, and then the slightly drier central moist forest, which is in a lighter green. And to the south, you, again, have a sort of a lower elevation southern dry forest, which is in orange and gray. Regarding our pathogens of concern, we did not find any equine anaplasmosis, Borrelia species, rickettsia species, or brucellosis. We did, however, find some premises that had ticks positive for equine pyro and bovine babesiosis, and a boatload of premises with ticks positive for both anaplasmosis and ehrlichiosis. You'll notice we pooled dairy cattle and beef cattle here, and the reason for that is that we didn't end up finding any significant difference between the 2 groups in terms of pathogen prevalence. As noted previously, the bovine babesia species have not yet been confirmed due to COVID delays, so there's a chance the number of bovine babesia positives will decrease once we rule out commensals, but 24.2% is not a totally unexpected finding. For the bovine anaplasmosis and ehrlichiosis, you'll note that we were not able to get the Ehrlichia species completely ironed out. For our own peace of mind, we did ask the laboratory to rule out Ehrlichia ruminatum, aka the causative agent of heart water, and they were able to do that for us.
Okay, so moving on in terms of results regarding tick distribution by ecozone, the results are summarized below. So our first row, we basically have numbers of premises, numbers and percentages of premises that had ticks, and that is broken down into tick species. And then second to last row, we have the premises without ticks. And if we look across, we go through the different ecozones. I'll basically focus mainly on the results in bold. So if you go across the first row, you'll see that in northern karst, we had 38.7% of premises that had ticks, where we found ticks. The central wet or rainforest premises, 34.1%. Central moist forest was 58.3%, and southern dry, 56.9%. So preliminary statistics have shown a statistical significance association between ecozone and presence of ticks. And what we found so far, concentrating on the central moist, is that the odds of finding ticks are about twice as more in the central moist forest premises compared with central wet and the northern karst regions. And then moving on to showing the results a little more visually, you'll see on the left side, you have a bar graph basically showing this result with the dark green bars being the ones that were showing the positive premises, so premises where we found ticks. And as you can see, the central moist forest has the bars a lot higher, has a lot more ticks that were found in this area compared to other areas. So when we look at the map, just reminding us of where this zone is, basically the central moist forest is what is shown in light green. And as you can see, it encompasses a big area of Puerto Rico. And as you will see later, it definitely is areas where we actively see ticks and where we actively have livestock. Then moving a little bit on to disease patterns themselves. So reminding everybody that these were diseases found or organisms or nucleic acid for organisms found in ticks. So we have the same thing, basically our list of diseases and on the rows, and then our columns basically involve the ecozones. So the most significant, a lot of this data so far, preliminary statistics have not been significant. But one thing that I did want to point out, basically, we can see a difference, even though we so far has not been statistically established. We see that the central moist forest, we had 43 positives for anaplasmas, which is 69.3% of those ticks. And then in terms of the same region, the ones that were positive for babesia and anaplasma together are 17.7% of those ticks. Then just to show things visually, you will see here, this is basically a map, basically just concentrating on horses and showing pyroplasmosis. So we had the dots that have red are basically the ones that were negative for pyro, and the ones in purple were the ones that were positive for pyro. And we were a little bit surprised by this result because compared to the numbers that we see in the field, this seemed like it's a pretty low number of pyro-positive premises. Then moving on to the cattle premises, again, it's just basically this map is to show visually our results. You'll see that the dots that have blue in them are basically the ones where we had anaplasmosis positive ticks. The ones in green are basically where we found ticks that were positive for both babesia and anaplasm. Negative were the reds, and as you can see, not many of them. There aren't many red dots. And then babesiosis only were the ones that are in yellow. Again, for babesia, we have things pending still. So things may change, but definitely wanted to point out the wide distribution of both of these diseases of anaplasmosis and babesiosis potentially across the entire island of Puerto Rico.
So here we summarize our notable findings. As noted, we had perfect host species, tick species correlation, and we did not find any brucellosis. One of the limitations of this study was the fact that ticks were not found on pigs, and blood is a low-yield sample for brucella. So ticks are probably not an optimal way to screen for swine brucellosis. Nevertheless, negative results are still of epidemiological value, and the fact that we could use ticks to supplement brucellosis surveillance was notable in of itself. We found the prevalence of bovine babesiosis in ticks on cattle to be 24.2%, which is almost exactly the same as the 26% seropositivity rate that was described in the Erdaz article in Puerto Rican dairy cattle. However, in the same study, Erdaz found a seroprevalence rate of only 27% for bovine anaplasmosis, whereas we found 3 times that with our tick study. While this does not necessarily indicate that all of the cattle with anaplasma-positive ticks had anaplasma, we do know that Rhipicephalus microplus and Rhipicephalus annulatus are competent vectors of anaplasma. Additionally, anaplasma marginale is not transovarially transmitted in Rhipicephalus microplus. The positive ticks were infected within their lifetime. They're also typically one-host ticks, so it's likely that they reflect infection from the host from which they were collected. This is to say that we believe the prevalence of bovine anaplasmosis in Puerto Rico is likely much higher than previously published. Meanwhile, only 9.8% of ticks collected from horse premises were positive for equine pyro, which is significantly less than the estimates of up to 89% that we had from the 70s. Notably, all of the positives that we found were positive for Babesia cabali. We did not detect any Theileria equi. The test we used was not validated for Theileria equi, so it is entirely possible we missed positives for that reason. However, in general, there are two reasons that we do not believe that we significantly underestimated equine pyro. The first is that the test, while not validated, has previously been used to detect other Theileria species. And the second is that serum samples that were submitted for testing to NVSL over the tick collection period, so not over the 2-year period that Dr. Rivera mentioned earlier, but just over this 1-year period, found a test positivity rate for equine pyro of about 16.8%. All of them were Babesia cabali, none of them were Theileria equi. The blood samples that are being submitted to NVSL are not randomly collected. The horses are tested sometimes multiple times, either because they need to prove that they were pyronegative in order to travel, or because the horses were clinically ill. As a result, we mention them as a general point of reference and not as an accurate estimation of true seroprevalence on the island. However, that 16.8% is still much closer to our tick estimate of 9.8% than the previous estimates of 89% for Babesia cabali or 25% for Theileria equi from the 70s. So again, as a result, we believe the true prevalence of equine pyro in Puerto Rico is likely less than what had previously been published. To summarize our impressions on the last of our research questions, we found that using ticks to perform disease surveillance did have some substantial benefits. It was much less stressful for both the animals and the people doing the collection to grab a couple of ticks than to take a blood sample. Most of our collections occurred alongside other tasks where we were already visiting the premise. And we were often able to leave tubes for producers to collect the ticks for us, which we could then just pick up. The field costs were very minimal, basically just tubes, ethanol, and shipping. They also allowed us to keep an eye on general trends within the overall environment without necessarily needing to wait for sick calls. And it allowed us to monitor both vectors and pathogens of concern, and not even for exclusively tick-borne pathogens. We would not recommend that ticks be a substitute for blood collection for surveillance in a control zone or in the case of a sick animal. A small quantity of blood present on the tick can have negative impacts on the sensitivity of some of these tests as compared to conventional blood tests. And of course, the laboratory costs, at least for right now, are higher because the small quantity of DNA you're getting requires additional cleanup steps. However, we believe this technique should be considered as a low-effort, low-stress complement to more traditional surveillance purposes, especially in areas with high tick loads. So originally, this slide with technical challenges was going to be for general challenges that we encountered, but other than not finding ticks on certain species, we didn't really have any significant field-level challenges. However, our laboratory partners reported a few more challenges that we think are noteworthy. In general, they found that the DNA of various Babesia species was a lot more sensitive to the freeze-thaw cycle than some of the other pathogens' DNA. It's unclear to me personally why this might be, but it did slow down the process rather considerably as they had to employ additional amplification techniques to achieve an adequate sample. The tick identification group encountered multiple morphotypes of ticks, so we ultimately had to rely on genetic testing for identification for many of our ticks. This is not a huge hardship, but it did add additional tests and costs to the project. I think for me, at least, the biggest learning point was the strong need to have species-level identification for any pathogens of concern. Ticks have many commensal organisms that can look similar to our pathogens until you drill down a bit more. Just as an example, we had originally thought we might have several equine rickettsia diseases, but then when we drilled down to the genus species level, they ultimately all ended up being spiroplasma species, which in our case were all tick commensals. So in other words, factor in the need for species-level precision into any costs that you have if you try a similar project, and don't get too excited by preliminary results.
So now, basically finishing us off with just the current update since we did that project. So recently we've had Puerto Rico in general, our Puerto Rico group is very active in regards to ticks, especially Rhipicephalus microplus. Recently, we've had some initiatives from certain equine groups, basically potentially interested in controlling pyraplasmosis in Puerto Rico. As we had said, it is endemic. And we have had meetings in regards to this when we brought everybody to the table, but it doesn't seem like it's necessarily a main interest for all groups involved. And considering that at least right now it's not a federal program as far as Puerto Rico goes, we don't have it as one of our programs other than import-export, where we do tick work with horses that basically remains there as far as pyraplasmosis goes. However, we've had some definite interest from the bovine industry, especially from the dairy cattle industry, from the dairy industry, mainly because, as you can imagine, they definitely see the direct impact that anaplasmosis, especially babesiosis, can have on herd health and the catastrophic effects that it could potentially have in some of these herds. So we've always been pretty active in regards to cattle. Right now, we're basically concentrating our efforts in, if you look at the map there, it's basically the white circle in the southeastern region in the municipality of Yabucoa, as basically we have an effort there to control. We had some complaints of an incredibly difficult to control tick population out of a certain dairy premise. So we're basically concentrating our efforts there and are actually treating it as an incident, or treating it right now as an emergency. So with that, these are basically our citations are included there. And then the most important slide of the presentations are acknowledgements. We would like to acknowledge, first of all, the Vision and Science Grassroots Grants Committee. Second of all, especially our field people in Puerto Rico. Our animal health technicians were the ones that did most of the bulk of the collections of ticks, and we definitely thank them for all their efforts. The Agricultural Research Service, which basically has collaborated and continues to collaborate with us in tick projects, especially Dr. Robert Miller and Jason Tidwell. And then out of the group in Texas A&M University, Dr. Lowell Stevie Gessent and Peyton Blackburn, who was basically the student that did most of the lab work. And then out of the University of Wyoming for the brucellosis samples, Dr. Brant Schumacher. And with that, we'll take some questions.
Great. So great presentation. We do have a comment, and the comment is you have to be careful just testing ticks. The presence of a pathogen in a tick doesn't always mean the host is infected.
Yes, and we completely agree with that, and I think it's very, very much worth emphasizing that. We were looking at, the presence of these pathogens in ticks, trying to get an idea of what was going on around the island. We would never have used this technique as a way of trying to test an individual animal for that particular disease.
Okay. So the next question comments, good project to answer some of practical questions to help in controlling diseases. I wonder if you've considered what is currently used xeno surveillance tools that are applied in Central America for human diseases. What is the application of xeno surveillance in PR for human VBD? And are you aware of this work?
I'm not personally aware of that particular work, although if you're using xenosurveillance to refer to sort of what we used here, which I've also heard referred to as iDNA surveillance, I being standing for invertebrate, I do think that there is a lot of different work going on around the world. It's sort of been one of these topics that's exploding. I've seen it with, in terms of both checking mosquitoes. I know there's some projects that are working on leeches. and we chose to use ticks in our particular example, but there are a lot of different opportunities out there using this xeno surveillance for both monitoring pathogens in the environment that affect animals as well as humans.
There's one other comment, and it's related to the mixing up of brucellosis with BBD. I do not see a significant link, and it may dilute the impact of this good work.
Sorry, could you repeat the question or the comment?
It says, my other comment is related to the mixing up of brucellosis with BBD. I do not see a significant link, and it may dilute the impact of this good work.
I'm not entirely sure what that particular comment is in reference to, but I will say that when it comes to the brucellosis, you know, as noted, we wanted to include it for a variety of different reasons, most of which is that we wanted it as a potential surveillance tool. We do recognize that there were pretty substantial limitations in terms of using this, obviously, as any sort of an exclusive surveillance tool. We would not want to do that. It was more of just a, could we try it? We knew that there was a new PCR out of the University of Wyoming, and we wanted to add it into our list. In regards to BVD, I'm unclear what that particular reference would be to.
There's another comment, excellent presentation. Thanks for providing this webinar. Is the stepless microplus a single host tick?
Just scrolling up through my notes here because I knew I was going to get a question about this, but I believe it is. Yes, it is.
Yeah. So VVD is vector-borne diseases. That was the comment.
I see. Okay, vector-borne diseases. I'm sorry, I heard BVD. That makes more sense then. And yes, I think that the point is well made that, you know, the brucellosis was a little bit more out there, honestly, than some of the vector-borne diseases. But we felt that it had value because there have been other projects that have been done where they used, again, this iDNA technique that they weren't necessarily looking for diseases that were being vectored. I mentioned specifically the leeches, but they're a potentially good example of that, where the leeches that they're looking for, they're not necessarily vectoring the diseases, they're just using them as little tiny syringes, basically going out collecting blood for them. So we do have evidence that the blood meal within the ticks, if we know that the pathogen of concern can survive within that blood meal, even if it's not being vectored, this still has potential utility there. In the case of brucellosis, maybe Puerto Rico was not the ideal place just because we don't suspect brucellosis, and again, we weren't finding ticks on pigs, and swine brucellosis was our big surveillance pathogen of concern. But I do think that there is still potential value to using ticks as sources for surveillance efforts, even for diseases that are not necessarily being vectored by those ticks.
Okay. So there's another comment. Xeno surveillance is not applied only to mosquito. Ticks were used in some part of the world.
Yes. We do not necessarily claim to be the first to be using ticks in this particular way. Totally agree.
Okay. Do we have any other questions? Have a lot of good, thank you, good job. Thanks for the presentation. And I'm so glad we got to finally get this done. We've changed the date a few times. So I thank everyone for joining us today. And this will be posted if there's people that want to watch this in about a week. It'll be posted on the NTEP video gallery for viewing. Oh, we do have one more question or comment. There was a recent publication out of New York City showing Asian longhorn ticks that fed on wildlife infected with various tick-borne diseases. The ALTs did not have the agents found in them.
And yes, I think that there's always going to be some sensitivity issues, as we mentioned, using this particular technique. Some of the diseases that we're looking for, like the brucellosis, the bacteria in blood is intermittent anyway, and ideally you're going to want a larger blood sample for some of these things. This isn't a perfect way of doing surveillance, and that's why we said that it would only ever be used as a complement. But it still did give us some highlights in terms of directions that we might be wanting to go within Puerto Rico, again, recognizing that, the incidence of anaplasmosis was much higher than what had previously been published. And pyro, at least, based on these early signs, it might be lower. And so I think this is more of an overall, again, complement to any additional surveillance systems that are be done, but it should never be used as a substitution.
And there's another comment. There are no pathogens yet found from ALHT except filaria in the U.S. And thank you for an interesting presentation.
We appreciate all of the great comments that are coming in from all the tick experts online.
All right. Well, we have their contact information. And with that, thanks everyone for joining us today, and have a great rest of your afternoon.